Hi everybody, it's time for another lesson. This time it's on gases and stoichiometry. So before we begin, you need to get out problem book 716, a calculator, and a pen or a pencil. So pause the video and come back and join me. Thanks for getting your supplies, and now we're going to start with some new information about gases. So we've dealt with equations before, and on the top of page 716 you have the equation for the production of ammonia, which is actually a very important reaction in chemistry. And we have nitrogen gas reacting with 3 hydrogen gas molecules to make 2 ammonia gas molecules. And we've used balanced equation to solve problems, but we can also use balanced equations in a new way if the molecules happen to be in gas form, like they are in this equation. So as we've done before, the numbers in front, and this is an implied 1 in front of the nitrogen, but the numbers in front of the equation tell us how many moles react. So 1 mole of nitrogen reacts with 3 moles of hydrogen to make 2 moles of ammonia. But because we are dealing with gases, we can also use something else. And we can also change these numbers. Instead of 1 mole reacting with 3 moles to make 2 moles, these numbers can all also represent volume. And how is that possible? Well, if all the gases are at the same temperature and pressure, which they are for problem book 716, if all the gases are at the same temperature and pressure, then the volumes are directly related to the moles. So if I have twice as much moles, I have twice as much volume. So the ratios in front of the balanced equation can now represent volume. So for instance, I have 1 liter of nitrogen gas can react with 3 liters of hydrogen gas to make 2 liters of ammonia gas. So let's try a problem where we would use this information. So go to problem book page 716 and look at problem B. And it says, what volume of hydrogen will be needed to react with 5 liters of nitrogen? And these are unit analysis problems, so hopefully you remember how to do these. So the first thing I do is read the problem, and it says, what volume of hydrogen? So I'm looking for volume, and in this case, let's do liters. What volume of hydrogen, so I'm going to do liters of hydrogen, are needed to react with 5 liters of nitrogen? So that's what I'm given, 5 liters of nitrogen. So now I have to go from liters of nitrogen to liters of hydrogen. And this is where our new information can come in. Because now, in my balanced equation, this ratio can represent moles, but it can also represent volume as long as we're dealing with gases at the same temperature and pressure. So 5 liters of nitrogen. I look at nitrogen on the balanced equation. I have 1 liter of nitrogen is needed to react with 3 liters of hydrogen. And liters of nitrogen cancel, and I end up with liters of hydrogen, which is what my answer is. So the math on this one is very simple. 5 times 3 gives me 15. And so my answer is 15 liters of hydrogen, 2 significant figures. And as you can see from the problem book, 15 is the answer given. So great. You can do these type of problems anytime that the molecules in a balanced equation are at the same temperature and pressure and they are gases. Another thing you can do with these problems, so I'm going to write the equation again, nitrogen plus 3 hydrogens, and these have to be gases for this to work, leads to 2 ammonia molecules in the form of gas. All right. Another thing that we can use is if this happens to be at the same temperature and pressure, and the same temperature and pressure happens to be standard temperature and pressure, I also know one more thing. I know that 1 mole of any gas at STP equals 22.4 liters. Right? And you can get this yourself if you want to by plugging it into the equation PV equals nRT. Okay. At standard temperature and pressure, we have 1 atmosphere. And if I wanted to know the volume and for 1 mole, and I'd have 0.08206 liter atmosphere moles Kelvin. And at standard temperature and pressure, the temperature happens to be 273.15. So if I plug this into the equation, I will find that the volume of 1 mole happens to be 22.4 liters at STP. And we can use this information when we're solving unit analysis. So this is a new piece of information I can use to solve unit analysis problems. So go to problem D on page 716 and let's do this one together. So the problem is for this same reaction, nitrogen reacting with hydrogen to form ammonia gas. And if I read problem D, it says at STP conditions, so that's important to know because at STP conditions, that's when 22.4 liters equals 1 mole. What volume of ammonia will be produced from 6 moles of nitrogen? So I read it and I'm looking for volume of ammonia. And I'm starting with 6.0 moles of nitrogen. So somehow I'm going to have to get from moles of nitrogen to liters of ammonia. So I'm going to have to get rid of moles of nitrogen. And remember, there's other things we can use to solve unit analysis problem. Do I need to use the periodic table? No, I'm not looking for grams, and I'm not given grams. I'm not going to use Avogadro's number because I'm not looking for molecules. But I do have a balanced equation, so I am going to need that because I have nitrogen and I want to get to ammonia. So I can use the balanced equation next. So I'm going to solve this problem 2 different ways. So we're going to solve it 2 different ways. What if I use the balanced equation next? So I have 1 mole of nitrogen will react to make 2 moles of ammonia. But I'm at moles of ammonia and I want to get to liters of ammonia. You might say, well, how can I do that? I don't have the molarity of the solution because it's really not a solution anyhow. But what other information do I know so I can go from moles to liters? Well, the new information I have is that there are 22.4 liters for every 1 mole of any gas, and this time the gas happens to be ammonia. So if I take my calculator out and multiply 6 times 2 times 22.4, I get the answer that's given in the problem book, 268.8 liters of ammonia. But the problem book has something wrong. You might notice that I do have 4 sig figs here, but this is not a definition. This is 3 significant figures. So I really should round this to 269 liters of ammonia. Okay. I said I was going to solve this 2 ways, so let's try this one more time. I have the equation here. I have the equation here of nitrogen gas reacting with 3 hydrogen gas to make 2 ammonia gas. And we're going to do problem D one more time to say we could have solved this 2 different ways and get the same results. So it says what volume of ammonia, so liters of ammonia, can be made from 6 moles of nitrogen. So now I have to get rid of moles of nitrogen, and I notice I want to get to liters of ammonia, and the problem says it's at STP conditions. So I could here, instead of using the balanced equation, do 22.4 liters of any gas, this happens to be nitrogen, is 1 mole of that gas at STP. And then I can cancel out the moles of nitrogen, and I have liters of nitrogen, but I still want to get to liters of ammonia. So now what do I do? Well, I can use the balanced equation and have the numbers in front represent the liters instead of the moles. So I have 1 liter of nitrogen, which produces 2 liters of ammonia. And I get out my calculator. 6 times 22.4 times 2 is the same as I did before. I have 268.8 liters, and I'm going to round that to 269 liters. So notice this time, I used that 22.4 liters first, and then I used my balanced equation using liters. And the time before, I used the balanced equation first in moles, and then the 22.4 liters next. So both methods get you to the correct answer. So hope you followed along, and thanks for listening. This is part 1. We'll continue to part 2.